have an example of a phase portrait. And let's consider this system. dx dt equal 8x plus 2y, and dy dt equal 6x plus 4y. Then, as I mentioned before, the first step is to consider the matrix. In this case, the matrix of this system is 8, 2, 6, and 4. And then to compute the characteristic equation, we need to compute the trace. In this case, the trace of A is 8 plus 4 is 12. And the determinant of A is 8 times 2 is 32 minus 12, which is 20. Then the characteristic equation is lambda squared minus 12 lambda plus 20 equals 0. We need to solve that, and in this case I believe factoring will work. Lambda minus something, and what is that? Factoring 4 times 5, 6, 2 times 10, right? 2 times 10 equals 0. That means that lambda equals 2 and lambda equals 10. We have two positive eigenvalues. That means that we have a source. In order to compute the directions of those two lines, we need to compute the eigenvectors. For lambda equal 2, we need to solve this system. We do A, parentheses, 8 minus 2 times x plus 2y equals 0. And we do 6x plus 4 minus the eigenvalue, which is 2 times y equals 0. And if everything is okay, these two equations are essentially the same. Let's see that. We have 6x plus 2y equals 0. And in this case, they are not essentially the same. They are exactly the same. One solution of that system is the vector. We can pick x equal 2 and y equal negative 6. This is one eigenvector. And for this one, we're going to do the same. Let's record this. We can pick the vector here, 2, negative 6, right? For this one, we do something similar. For lambda equal 10, we have 8 minus the eigenvalue lambda times x plus 2y equals 0, and 6x plus 4 minus 10 times y equals 0. These two equations are supposed to be essentially the same. Let's see, here we have negative 2x plus 2y equals 0, and here we have 6x minus 6y equals 0. And one solution for that, we can take x equal 1 and y equal 1. X equal 1 and y equal 1 satisfy both equations, and that means that we have our second eigenvector. Then for lambda equal 2, we have 2, negative 6, and for lambda equal 10, we have the vector 1, 1. Then to do the phase portrait, we first do the origin, 0, 0. And then we do the vector. Let's do the Cartesian axis like this. We do 2, negative 6, 2, negative 6. We do this vector here, 2, negative 6. And then this is one of the lines that we have to draw. Right? And we're going to label this lambda equal 2, because this vector, this line, has to do with this eigenvector lambda equals 2. Notice that we have to visualize this not as a line, but as two semilines, this semiline and that semiline. In this case, for lambda equal 10, we have the vector 1, 1. We connect 1, 1 with the origin, and we got the second line. And we should see this as two semilines. And we're going to label here this lambda equal 10 because this line comes from this eigenvalue. Let's forget about the axis and let's just leave the lines. We have like 4 quadrants, and in this case this is a source. This lambda is positive, that means that the arrows in this semi-line is going out, and since lambda is equal 10, the arrow in this semi-line is going out. Then the other orbits that we need to do, they kind of look like a parabola, but in order to decide near the origin if they are tangent, there are 2 possibilities. They could be tangent to this line or to that line. In order to check, we need to think about the eigenvalues. One eigenvalue is 2, the other eigenvalue is 10. Which one is closer to the origin? Which one is closer to 0? This one is closer to 0. Since this eigenvalue is closer to 0, that means that this line, which is this line, is the one that makes the role of the x-axis in that parabola. That means that the parabola is going to look like almost tangent to this. Remember, I'm doing this like touching the semi-line, but they are not, right? This is too thick to make it not to touch, but it's almost tangent. And then far away is parallel to this. It is not indeed a parabola because far away is almost parallel to this line, close is almost tangent. Notice that I could draw like another one, and it will fit like right in between, and it will never touch neither this one nor that one. The other one will look like this. The direction goes out. The other one will look like this. Far away is parallel, close is almost tangent to this direction, and the other way goes like this. And here we have, remember, this is an example of a source. We have 2 different eigenvalues, they are positive. We find the 2 lines that we should visualize as semi-lines, and we have drawn the 9 orbits. 1, 2, 3, 4, 5, 6, 7, 8, and 9 orbits. Okay, this is it for the example of a source.